Now, we've got this tool, tools to solve the quadratic equations. What makes an equation quadratic?
The square root, or not square root, sorry, the second power.
Squared, right? X squared, okay? So if we have x squared, it's quadratic, okay? Well, we can have some equations that aren't x squared or don't have an x squared, but we can still use these tools, these methods, to solve them, okay? And these are what we call equations that are reducible to quadratic, or they're in quadratic form, all right? And so that's very bouncy, isn't that? Okay, so that's very bouncy there. Okay, so quadratic form means we can write it like this. Something times, let's say u squared, plus b times u plus c, and a, b, and c are just numbers, okay? So if we can change it up to make it look like this, then we can solve it using the methods we just learned, okay? So that's the key, okay? It needs to be a trinomial. That means it has three terms, okay? It needs to be in this form, okay? So the first step is to set it equal to 0, determine if it's quadratic form, and we're going to define this u. We're going to kind of redefine things, and we're going to change variables, okay, to make it go from ugly to not so ugly. And then we're going to substitute and solve and plug it back in. Okay, that's a lot of steps, but you'll see here. Okay, so first thing we got to do is to determine if this is in quadratic form. Okay, and then we'll define a value of u. So, is this a quadratic equation? Not really. It's x to the fourth. X to the fourth is not quadratic. But what if we wrote it like this? X squared squared minus 5 times x squared plus 6 equals 0. Is that equivalent? Yeah? All right. X squared squared is x to the fourth, and we threw in some extra parentheses there for some reason. Well,
you want to do it minus 5x times x?
Well, I'm thinking I like the fact that these are both x squared. And because of this, now, if we say u is x squared, proper grammar here, okay? So u equals x squared. Let's just say that. Let's just define that. Then what we're going to be able to do is we're going to be able to swap this out for x squared. And so we can put, since I've just decided just for kicks that u is the same as x squared, we could rewrite this as u squared minus 5u plus 6. We could swap out because we're going to define u as x squared. Okay? All right. So we'll leave it at that for now. We're not going to solve anything. Okay, but the key here is u equals x squared. Okay, that is what we want to substitute. Nope, for that equation.
Just that equation.
Okay, we're going to come back and solve that in a moment. This is step 1. We're just going to focus on step 1. All right, all right. How about this? Ooh, there's an ugly equation. Is it quadratic? Not really. What would you like u to be? X squared. Anything else? I notice we've got this, those parentheses squared plus 1, if you want, times those parentheses minus 5. So we've got something squared plus 1 times that same something minus 5. Okay? So if we let u equals x squared minus 3, then this is now u squared plus u minus 5 equals 0. And that's not so intimidating. All right? If we just showed you that, You could probably deal with that, right? Solve it for u. Okay, it's just a different variable instead of x. Yeah.
I'm just a little bit confused about how you just define u as whatever. Oh, is it the whatever happens to be squared in the?
That sounds like it works pretty good.
Got you. Okay.
Yeah, so we're kind of developing that idea of why did we pick that? Okay? See, if we said this, if we said, well, let's make u equal to x squared. Well, that would just get us to here. U minus 3 squared plus u minus 3 minus 5. Okay? If we swapped out u for x squared, it wouldn't do much for us. Okay? So this was a better choice. All right? All right. Well, how about the next one there? Ooh. That's strange. What if we rewrote this with some exponents? What is the square root of x? What's another way to write that? X squared, right? Nope. Try it. Close. 1/2, maybe?
Oh, yes.
Okay, good. It's all good. Okay. Oh. Well, this is, could we call this x to the 2/2 maybe?
Yeah.
Oh, jeez.
Or could we say maybe,
Just making stuff up now.
could we call this, we're going to see a pattern here. Could we call this x to the 1/2 squared? Sure, why not? Okay,
Can we
x.
just call it you?
That's right. Let's call it you. That's right. You know, it's.
Can we just call it you?
Yeah, whatever you want. You know, this is new math.
Let's make up math.
Okay, so yeah, we can use your imaginary numbers and just whatever. You know, 1/2 to the squared is 1. Okay, so we've got to make a connection. We've got to make a connection here between the first and second term, right? This was x squared. This was x to the 4th. This was parentheses to the first. This was parentheses squared. Okay? This was x to the 1/2 and x to the 1. So how many times bigger is the power on this than the power on this?
Twice.
Twice as big, right? 4 is twice as big as 2. 2 is twice as big as 1. Okay? 1 is twice as big as 1/2. So here we're going to want u to be that x to the 1/2. All right? And then when we swap it out, which we'll do in a moment, we get u squared plus 8u minus 9 equals 0. And we can deal with that. Okay?
Could you explain to me
Yeah.
how you got the x 1/2 squared?
What is 1/2 squared? So power to power, we multiply the exponents. Right?
Oh, okay.
Power to power, we multiply, and that gives us that little invisible 1 there, right?
Makes sense.
Okay?
Can you just put down u squared plus the variable u minus the
All
number?
right. Is this in quadratic form? Is this power twice as big as this power?
Twice as small.
Okay, twice as small. 2 times -1, is that -2? Yes. So this, I'm going to just kind of put some parentheses there. I think that's my u.
So are you basically doing whatever you can do the first 2 to make things alike, to take it out as you?
Yes. Yeah, that's a good way to say it. We're trying to get something squared, right? A times something squared plus B times that same something plus C equals 0.
And it's always the first 2 terms that you're trying to make alike.
That's right. Because we want it to look like that ax squared plus bx plus c equals 0.
Yeah, so if you have m to the negative 1 and you square that,
Yep.
if you square the x, well, wouldn't you have m to the positive 1?
No, because you don't square the power, you multiply the power. We multiply the power. Okay?
One time.
Because the negative makes it 1 over, right?
So it'd be
Okay.
Yeah.
U.
So u is m to the negative 1. That's all we care about right now, okay? We're going to go to the next step in a moment. Let's just get comfortable with the u thing. All right, take it a step further. Is this power twice as big as this power? Yeah. So it's in quadratic form, right? We've got a variable to a power, a variable to half as big a power, and no variable.
So it'd be t to the third squared.
T to the third, that's right. Okay. So now this step here is just kind of verifying. Yeah. Okay, so we got parentheses squared minus a parentheses minus 2. Okay. So what's your u?
T to the third.
T to the third. Okay.
Is t to the third going to come back into play?
Yes, it is. We're going to solve all these in just a moment. Okay. That second step there, once you get the hang of this, you don't need to write that second step out. Okay? But that's what's going on, all right?
The next one's easy.
Yeah, that's easy, right? Piece of cake. What is u?
10 minus square root of.
It's there you go. Okay? Because when we just swap out u for all of this, we make just a big fat u. Okay? Sorry, I didn't call you fat there. That was not what I said. Okay. All right. Getting the hang of that? So we defined a u. Now you might be saying, so what? Why does that help us? Well, it's going to take a difficult equation and make it simpler. Okay? Do you know how to solve? This is quartic. X to the fourth is quartic is what it's called. This is a quartic. Well, I don't know how to solve a quartic equation. All right, but let's do the whole deal here. We're going to say, first we're going to define u. What was u for this one? X squared. Okay, so we're going to walk through the whole thing. Question? Don?
Well, never mind. It's a question about the answer, so just.
Okay, so so now we're going to rewrite. So this is x squared squared, right? X squared squared. Okay, so this is going to be u squared minus 5 times u plus 6 equals 0. Let me, let's see, can I do this? Okay. Oh. Okay, so let me go ahead and write out that in-betweener. This is optional here, but I'll write this out again. This is x squared squared minus 5 times x squared plus 6 equals 0. So we're substituting, we're swapping out x squared for u, okay? And we get this guy here. Okay, now let's solve this. I think we can factor this. In other words, add the negative 5 and multiply to 6.
Negative 2 and negative 3.
Okay, so there's maybe a 2 and a 3 or a 6 and a 1. Okay, that's good. That's all right. I think we're thinking 2 and 3, right? Oh, that's a good catch. Thank you, thank you, thank you. There's no x here. U, thank you. U. Okay, we're solving for u right now.
So u equals 2
Is negative
or
2.
u equals 3.
So u equals 2 or u equals 3. Question?
So the second step from the last one, that's factoring?
That's factoring, yep, yep.
So
If we can factor, that's kind of the quickest and easiest way to solve a quadratic equation. So most of these are going to be factoring because we don't want to mess with the other ones right now. Okay, are we done?
no.
Oh,
Put
good.
U back in.
Ah, what is u?
2 or 3.
u is?
U is.
u is x squared. It's how we talk. I just moved to Gold Hill. Actually, no, I moved to the suburbs of Gold Hill. I don't live in Gold Hill.
Yeah, whatever.
There is.
Grants Pass.
That's right.
Gold Hill has suburbs?
Yeah.
We've lived in Grants Pass the last 18 years. No. So. Okay, so we swap out. So we got to solve for x squared, so we put it back in. And it should be pretty easy to solve. X is the square root of 2. I'm halfway correct there. Plus or minus.
Oh my God.
Okay, so let's back up. Let's back up because, okay, we put it in terms of u. We solved for u. But our ultimate goal is not to figure out what u is. Our ultimate goal is to figure out what x is. So we're going to resubstitute. We're going to put x squared back in and keep rolling here. And when we do that, we get x squared equals 2 and x squared equals 3. That's a simple equation to solve, square root. This is a simple equation to solve, hopefully. Square roots. Square roots. And x is plus or minus the square root of 3. So we actually get 4 answers. Okay? 4 answers. Positive square root of 2, negative square root of 2, positive square root of 3, negative square root of 3. Okay? All right, let's keep cruising here. Okay? What is our u here?
X squared minus 3.
It's the x squared minus 3, the parenthesis thing. Okay? So we trade it out. U squared plus u minus 5 equals 0. Okay? We can solve that equation. I think we can factor again. This is not meant to be challenging here. This part here, right? 2 numbers add to 1 and multiply to negative 5. I think we got some more 2s and 3s, huh? No, 5s and 1? Oh. Oh, this doesn't work.
No. You're like, this is too crazy.
Ah, this was supposed to be easy. I think we're going to make this easy.
Yeah.
So we don't go crazy. I'm going to change this to, how about a 4? Okay, let's imagine that there was a 4 in there.
Now it's 4.
Okay.
For you.
Okay. All right. Let's just. Otherwise, you'd have to use the quadratic formula, and it would get ugly. Okay. So I'm going to. So let's see. We could do that, right? 2 numbers that add to 4 and multiply to negative 5. Okay. Now we can factor. Okay. All right. So I'm going to do that because I don't want to spend a bunch of time with a bunch of ugly numbers
Yeah,
here.
let's not.
Okay, we could have done that. We could have done the quadratic formula, but I think everybody would walk out. Okay?
I think you might be right.
So, u, plus 5 minus 1, right?
I just put it in.
Okay. So u equals negative 5 makes the first one 0. U equals 1 makes the second one 0. So, are we done?
No. It's negative
No.
5 squared minus 3.
Now we got to plug it back in.
Squared.
No?
No, it's okay, we can stop.
We can stop, huh? X squared minus 3 equals negative, okay, two equations.
And then you plus 3.
Solve them separately, add 3.
That's what we did on last
Square roots.
one. But it's happening on the other side.
Okay, so x squared add 3, negative 2. Uh-oh.
There's two,
We're adding them
wait,
Okay.
plus or minus 2i.
Yeah, so this will be x equals plus or minus
I square root.
I, still the square root of 2. So 2 real answers, 2 imaginary answers. Sound good? Yes.
So when we do a question like this in my open math?
You'd list them out, 2, comma, negative 2, comma, I squared root of 2, comma, negative I squared root of 2. 4 answers. Yeah, really. Which is good because it's important to understand. Sometimes when we write this plus or minus stuff, we lose track of the fact that there's multiple answers there. It looks like there's one. Remember, there's 2 there, all right?
So that was x equals.
All right, what's our u substitution here? X to the 1/2, right? Because this is x plus 8 times x to the 1/2 minus 9. You might notice, by the way, we're just choosing this for our u. Whatever this term is, that's our u, and then this is u squared. That's really all that matters.
But, you said- okay.
Right?
Yep.
But why, the 8's part of that same term, that's not in you.
Well, the variable part of it.
Yeah.
Yeah, not the coefficient. So this is going to be u squared plus 8u minus 9 equals 0. Again, if this didn't factor, we'd have to do other things with it. But that's not the point of this, is not to have a lot of pain and suffering.
That's next,
That's right.
right? That's
Pain,
next week.
pain and suffering is next week. Uh-oh. Tag team. Oh. No, we're too far. Sorry. All right, so u equals negative 9 or u equals 1. And we said x to the 1/2. So this is x to the 1/2. Or if you want to write it as, well, let's go ahead and write it 1/2. You can write a square root if you want. And x to the 1/2 equals 1. Yes?
Can you explain what you did on the second step?
Yeah. The substitution?
Yes.
So we defined u as x to the 1/2, which is the square root of x, right? So this step we just rewrote, right? Okay. And so if x to the 1/2 is u, well, x to the 1/2 squared is x to the first. So this is just u squared. All right. Now that's the first thing we've got to check. You can't even really do this. This won't help us at all. Don't waste your time substituting if this is not this thing squared. If it's not, then this whole thing doesn't work. Okay, so. All right. Well, how do we finish that off? How do I get rid of that exponent? Square it. So square, square. So x equals 1. Square, square, x equals 81.
Isn't it plus or minus then?
No, we didn't square root.
Oh.
We squared. All right, but remember those radicals? They can be trouble sometime, right? So those radicals can be trouble. Should we just accept those answers? Should we accept what every radical says? No. Okay, so we should check it. We should check it. One of these I know is not going to work. Okay, so we got to check it out. So we've got to see, is 1 plus 8 times the square root of 1 minus 9 equal to 0? I think that is. That's 8, right? 8 times 1 plus 1 is 9. This is 9 minus 9, right? This is 9 minus 9, which is 0. Check. Okay, that works. This guy's good. What about 81? Plug in 81 for x in the equation. 81 plus 8 times the square root of 81 minus 9. Is that equal to 0? No. Okay, this is, no, 81 plus some big number minus 9 does not equal 0. Okay, for sure. Okay, does anybody know where we could have thrown this out? There is a false statement somewhere in this thing.
How is it this negative?
X to the half equals -9.
Square root of x equals -9. Is that possible? No, the square root of x can never be a negative number. Red flag, red flag. This is not going to be an answer that works. Okay, so there's only one solution there. So whenever you have radicals, you got to double check your answer. Okay, you get an extraneous solution is what they're called. Okay. All right. All right. Well, what do we get here? What's u? Okay, m to the -1. So this is going to be 5u. And this is going to be 2u squared. That thing's kind of trouble.
Yeah.
All right. I wonder if AC will work on here. 20, I think it will. I think it will. 2 times -12 is -24, right? Are there two things that add to -5?
Our Apple Watches are telling us to breathe, so you're stressing us out.
-24. Add the -5 and multiply to -24. 6 and 4 makes 24? Nah. 12 and 2? No. 8 and 3 makes 24? Yeah. 8 and 3 is promising. I like 8 and 3. 8 and 3 makes 5, right? When you add or subtract. So 8 and 3 sound like good numbers. So we have an 8u and a 3, so it's going to need to be a -8 and a +3. Split them on up. I think we can pull out a 2u. Like that. See if you can polish it off. Then factor it up. Find out what u is. Resubstitute. So that's what m is. So what's m? That's m to the -1. You write two separate equations.
So you
What is m to the -1?
it's negative first power, so it's 1 over x.
Over again. You write it as 1 over again.
Just kidding.
factor it?
Kind of,
that's what I
did.
Okay, okay, you cheated a little bit there. Yeah, well, you never really wrote it back and forth, right? Like this. So you skipped a step. So this is our factors form. U minus 4, 2u plus 3. No, you never, okay, so you skipped that. Yeah, that's right. So there's just a little bit of danger going on there. Danger zone. Danger with that's right. So factor this out, and you're gonna get that, yes.
I'm just gonna wait.
But be careful, because you might lose a plus or minus in there. So now you got your 2. So this is what is 0, so now you get a 0. How we doing?
I'm waiting for you because I'll keep myself the wrong way. I don't even know if I
Oh,
got
that's
it.
great. Equals, bring you that equals 0. So now when you break into two equations, this equals 0 and this equals 0. What does n to negative 1 mean? What does negative? Of course, 1 over. So write it out. 1 over n equals 4. Then cross multiplying. What does n to negative 1 mean? I know. So that's good. That's the tricky part there. Okay, so let's see. This has got like a little bit of everything, huh? U minus 4 times 2u plus 3 equals 0. So u minus 4 equals 0. 2u plus 3 equals 0, right? And u equals 4. And subtract 3 divided by 2, negative 3 halves. Are we okay with that? Okay. Now, here's a little different, challenging part. What is u? M to the negative 1. And what does m to the negative 1 mean? 1 over m. What do we do with that? Well, you can think of this a couple ways. You can cross multiply, make it a proportion, and cross multiply. Okay? What's really going to happen is they're going to end up just flipping. If you watch what happens, they're going to flip. Okay? M times 4, 1 times 1. 4m equals 1. Divide by 4. M equals 1/4.
So
What is that R word I heard back there? It's a reciprocal, okay? It's a m to the negative 1 is reciprocal, all right? This is the inverse of m, and it's going to flip that, okay? This is m to the negative 1 equals negative 3 halves, which is 1 over m equals negative 3 halves. Do you know what the answer is going to be if you cross multiply? It's going to be negative 2/3. Okay, and this is a property of proportions. Right now it's a proportion. Fraction equals fraction. Cross multiply and divide, and what you will get, and this would be an acceptable thing to memorize, is this. Okay? All right, well, if you want to see that, cross multiply and you'll get there, all right? So that's the big idea, okay? So we won't drag it out for these guys here. Well, I'm just going to leave it at this. Find the x-intercepts, okay? X-intercepts are where it crosses the x-axis, okay? And the way we find x-intercepts, like we were looking at the graphs before, is when we set this equal to 0. And that's going to be an important thing for Thursday, all right? So that's all we're doing. Oh, well, that's what we've been doing the whole time. So the moral of the story is the x-intercepts are the solution where this equals 0, all right? Thursday, bring stacks. because we've got lots to do, and it's going to be a good time, okay? So look forward to seeing you guys then. I'll adjust a couple of due dates there on the online homeworks because like we didn't even touch 9-5 tonight, so I'm going to make sure you have plenty of time for that, okay? So thanks guys, good job. We'll see you later, and I'll send you a couple little videos for these things that we didn't quite get to there to polish it off. Quiz, yes, please. Leave your quiz here.
When is this other quiz due?
Oh, when is that other one due? That one is due.